Hi everyone, this is 8.8 notes on solving linear and quadratic systems. As opposed to just two lines, we're going to have a line with a quadratic. So you could end up with two solutions where the graphs intersect, maybe only one solution, or possibly they might not cross at all, so no solutions. So let's do one algebraically and graphically. Algebra is always different every time. You got to look really carefully at what you have. These are both equal to y. Y is x minus 3. Y is x squared minus x minus 6. So that tells me that x minus 3 is equal to x squared minus x minus 6. When you're solving a quadratic, I always try to keep the x squared positive. So I'm going to move the x and add the 3 similarly over to the other side. Collect some like terms. And now it's equal to 0. Remember, solving, you got to find the x values that'll make this equal to 0. And then you're going to go back and find the y values. So you are going to factor this because it's simple to factor. Two numbers that multiply to be negative 3. I'm thinking negative 3 and a positive 1, because when I add those together, I would have negative 2. That's my middle number. Set your factors equal to 0. By the way, you could have done that by using the box method. So this is x minus 3 equals 0. Add 3. X plus 1 would equal 0. Subtract 1. I have 3 and negative 1 for my x values, and I'm going to go back to an easy equation and find, I got to write it twice because I'm going to use it twice, find the y value that goes with each x value. So if x is 3, it's 3 minus 3, so y would equal 0. 3 zeros, one of the answers. And then put the negative 1 in, so negative 1 minus 3, so y would equal negative 4. Negative 1, negative 4 is another answer. So there's two answers. These are written like ordered pairs. Graphically, this is a line. The slope is 1, and the y-intercept is negative 3. I'm just very quickly starting from negative 3, going up 1 over 1. Starting from negative 3, I'm reversing the pattern. So this is just a straight line. And you could label your equation with the equation y equals x minus 3. Graphing the parabola, I likely would have gone graph table and plotted some points. And so I did that. And I found this graph. I actually, on the graph, can easily see where they intersect. So there's my two intersection points. You could use this when you're practicing on your calculator at school. Menu, analyze graph, intersect will help you find these intersection points. You can also see on the table negative 1, negative 4, because they both have the same y value there, and 3, 0. So let's see. I'm going to try to plot some of these points. The turning point, if you look at the pattern on the quadratic, is somewhere between 0 and 1. So I have negative 1, negative 4, 0, negative 6, negative 1, negative 4, 1, 2, 3, 4, 0, negative 6. I had this point, and then I'm using some symmetry, plotting some other points. I know they cross there. So I'm just plotting the points off my graphing calculator. Dips down a little. By the way, I didn't see how low it dipped. So don't make this a flat bottom parabola. It does not do that. That's a bad thing to do. Plot the points, Look where they intersect. But I just changed that pen color, but I didn't. And you should see 3, 0. It's a good idea to label them. -1, -4. You can easily see where they intersect when you graph them. Number 2, I actually already graphed this one for you in the interest of time. So I went to a graphing calculator, and here's my table so that I could plot the points. I started with the turning point at -3, -1. It was a nice turning point. -4, 0. -5, 3. And then I used symmetry and plotted some other points. You could do that too. Battery running low. The line equation, if I subtract x, I get y equals -x minus 2. And I can see my slope and my y-intercept. So I started at -2, up 1 over 1, up 1 over 1. Keep doing that, and you'll see where they cross. I went through that quickly so that I could spend some time with some algebra. Y is equal to x squared plus 6x plus 8, and x plus y is equal to -2. So I'm going to replace the y with the mess. I have x plus something big equals -2, and that something is x squared plus 6x plus 8. I'm using substitution. All right, since I'm just adding, I don't really need these parentheses, so I'm just going to write it without the parentheses. And I'm going to make it look like a quadratic in standard form by combining those like terms and adding the 2 over. This is very, very, very easy to factor, I hope. X and x, two numbers that multiply to be 10. I'm going to use 5 and 2. Everything's positive. That makes my 7 if you check the outers and the inners or use the box method. X plus 5 equals 0. Subtract the 5 over to the other side and you're going to get a -5. X plus 2 equals 0. Subtract the 2 and you get -2. So you can see the -5, you can see the -2. There's no reason to get these wrong because you can check them both ways. Go back to the easier equation. I would say that is the x plus y equals -2, x plus y equals -2, and find y. So put the -5 in for the x, add the 5 over to the other side to get y alone. So there's my point, -5 gave me a 3. When I put -5 in for the x over here, oh, I'm sorry, not -5 this time, I just did that, silly. So this time you're going to put in your -2 for x equals -2. I'm just using that equation again, add 2, and there's my 0. So when I put -2 in, I got a 0 out, and there's my point I already had. So you can prove that you were right. On the next example, on the next page, we're just going to solve this one graphically. So I went to a graph and I looked at a table, plotted the points on my graph. I'll do the line that way, starting at -3, using the slope and the y-intercept without a graphing calculator would be easy, because you can go down 1 and count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm using my slope. Reverse it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I have this very not so steep line. I would label it y equals -1/5 x minus 3. I would do this one definitely by going to a graph and making a table and plotting the points, and then using analyze intersection. So again, graphically it would look like this. When you can solve them both for y, you can enter them as functions, and you can see what value gives you the same y value. So 5, -4 is the answer. It only crosses in one place. Using the Analyze and Intersect feature, menu 6.4, you can use these dotted lines that allow you to surround where it intersects, and it will highlight that point for you and immediately label it as the intersection point. Plotting points for your parabola, you would look for the pattern. So here I noticed the pattern on the table. 5, 1, 2, 3, 4, 5, -4 is the turning point. 4, -3, and 6, -3. And then let's see, 3, 0, and 4, 5, 6, 7, 0. For some reason, my pen just decided not to write anymore. That's very strange. I think it's because my computer's dying. Okay, I think I got my pen working again. This graph doesn't look very pretty over here, but I'm just plotting points from the table. So the first one was the line equation points, which I did that by slope and y-intercept, but the second list over here with the 0 and the -3 and the 4, so this got kind of messy, but I'm just plotting these points over here. They are the parabola. And I noticed that, of course, after plotting these points, 5, -4 is the only place where they intersect. So I would circle it and I would label it 5, -4. So you only had to do that one graphically. Then on to question number 4. Oh shoot, where is it? Down at the bottom of the page. There it is. So the profit Dell makes on a computer is modeled by this function. I'm going to call this function P of n. We left out the P there. So P of n, I'm going to rewrite as f of x, because when I go to my calculator, it's going to be like f1 of x, -50x² plus 300x, where n is the number of computers in thousands. So if you get a 5, that means 5,000. And the cost of to manufacture a computer is modeled by the function, oh, this is the cost as opposed to the profit. So C of n, why not just call that like f2 of x, because I'm going to want x's, is 600 minus 50x. Determine the number of computers. Okay, that's n, or in my case, x now, where the profit and the cost are the same, which tells me I'm looking for where they're equal. Then determine the dollar amount this happens at. Okay, let's take a look at this. Algebraically, I want them to be the same, so I want -50x² plus 300x to be equal to 600 minus 50x. Okay, this is a quadratic. You have to recognize that it's a quadratic. It's got a square. And I want the square to be positive, so I'm going to add the 50x² over to the other side. It doesn't go with anything, but I'll just put it over there for now. And I am going to subtract the 300x over to the other side also, and combine like terms. Here's my 0. Now over here, I have my 50x² first in standard form. I have to have the x² first, then I'm going to look at the x's. I have a -50 and a -300, -350x. This little old 600 is all alone, so plus 600 for the constant. This looks like a hot mess. You could use the quadratic formula on it, but I see a factor of 50 in each of these terms. So if I take a GCF of 50 out front, it's going to make it very easy to factor. So I'm going to pull the 50 out front and leave myself with x² by dividing it out, minus 7x plus 12. Then I'm going to put the equal 0 over there because that's where I'm comfortable with it. The 50 that I just pulled out, I could divide away on both sides and not affect the 0, because 0 divided by 50 is still 0. So really I'm just focused on factoring what's left. So this is like a factor completely question from Unit 6. I had to take the GCF out and I keep factoring. 12. I could use 4 and 3. If they are, that's a positive, so if they're both negative, that would be great, because I need a negative 7 in the middle. And a negative 4x plus a negative 3x will give me my negative 7x. Again, the box method if you need to see those pieces. I have my factors. I can set them equal to 0. Add 4, so I'd get 4. Set x minus 3 equal to 0. Don't forget your equals 0. I've been telling you guys it's important. It really is. Add 3 to the other side. X equals 3. Wait a minute. Something's wrong. Nope, I lied. Okay, so my signs are right. I got minus 4s. I got 4s and 3s. All right, let's see what happens now when I go to find my y values. So this is acting like y over here. So y would be 600 minus 50x. I'm going to use the easier equation, 600 minus 50x, and I'm going to put my numbers in. So when I put in a 4, 600 minus 50 times 4, 600 minus 50 times, put my 3 in. So y equals 600 minus 200, I get 400. So 400, and 600 minus 150 will be 450, I think. 5 cents, 450. So 3 gave me 450. So I have two answers to the question. When I sell 4,000 computers, what does it say? Determine the dollar amount this happens at. I'm at $400 in profit and in cost. And when I sell 3,000 computers, I'm at $450 in profit and cost. Profit and cost, where they're equal. Just to get a real quick visual of this, because you totally could have done this on your graphing calculator. It's an upside down with a negative slope, and there were two places where it intersected. Thank you for joining me. Try that one graphically when you get to class and see if you can get a picture, because mine turned out looking like this, and I would want to do a menu, zoom, fit, maybe a zoom fit. Let's see. Ooh, and then I can see where they intersect. To me, it only looks like I found one intersection point, but there might be another one in there. You should play around with that. Have fun.